Well, so last time I did give you that problem to think of, and hopefully on your homework you realize how to use the LCD to make your common denominators, add or subtract them, do all that fun stuff, and it was not too bad. Now, what we talked about the very last 2 minutes of class last time was that problem, and I wanted to refresh your memory on how to do that. I had you think about that for a little bit at least. And I said, do you remember the difference between something like this and something that was on your homework? What is here that was not on your homework? Yeah, that makes a big difference in how we go about doing this problem. If there's no equal sign, all we can do is manipulate those expressions. We can't really get rid of denominators. If we have an equal sign though, you need to be paying attention to that. When you have an equal sign though, what you can do, from our very first day of class basically, you can get rid of those denominators. Do you remember how to do that? Do you remember that we could do that first of all? Do you remember that from our first day? Yeah. That we could get rid of denominators? I hope you do. What's the first thing we would need to do in order to get rid of denominators? Yeah, you know what? That's the same thing we did in your homework, right? And pretty much everything you're going to do has to do with LCD somehow. Unless you're multiplying or dividing them, because then we don't even care about it. We just cross things out. That's what we do. So with this type of problem, the first thing we need to do, just like anything else, just like on your homework, we're going to find the LCD. So on our steps, which we're going to write down right now, hopefully you're waking up. Some of you guys look tired today. Man, you got to wake this up today. This is a good lesson. I practiced this one over the weekend, like in the mirror and stuff. No, I'm just kidding. But you need to have this one down. What's really important is that you see the difference between this section and the last section. I cannot have you do the same thing. You do the same thing on this section, you do the last section, you're going to mess yourselves up so bad you're never going to finish the problem. All right, you have to see the difference here. So first big difference, these have equal signs. That's why we're going to do it completely different. One thing is similar is step number 1, you must find the LCD. And in order to find the LCD, you might have to factor first. We learned that on your homework, right? You had to factor those denominators in order to find that. So you might have to factor this first. Let's go ahead and do this with this example. Now, this is kind of an easier one because, well, we have just numbers, but let's practice that. What is the LCD in this case? 20. Is it 20 from these two or 20 when you consider all three of them? What should I do? Okay, so we're still looking at every fraction you have, and we're going to take LCD is 20. And I'm going to rewrite this problem down here because I'm going to show you what to do. I need to have a little bit more space, though. Here's where the differences happen. And this is what you need to see in this section. Last time, what you would do in the last section, if there was no equal sign, is right now, pay attention on the board real quick, what you'd be doing is you'd multiply this by 5 over 5, this by 4 over 4. Are you with me on that? And you get 20. That happens if you don't have an equal sign, because you don't have two sides of anything, right? You just have expressions that are added or subtracted. When we have two sides, the process changes. We're going to use the fact that we have two sides of an equation and the fact that I can multiply each side, or in other words, every term. Those words should be ringing a bell for you the first day of class, first week of class. That if I have two sides and I multiply every term by the same number, it's still equal. So instead of doing the 4 over 4 and the 5 over 5, we're going to make this a little bit easier. We're going to go ahead and eliminate the denominators in one step by taking the LCD and multiplying every term by the LCD. This is what we did the first day of class, is we got rid of fractions this way. So what I mean by that, hopefully this looks familiar to you. We say, okay, what's our LCD? Oh, we have 20. What we're going to do with that 20? We're going to multiply both sides. When you multiply both sides of an equation, we get that the equation is still a true statement. So we'll say, I'm going to multiply both sides. If you remember both sides, that meant every term. If you don't remember that, go back and watch that video. We've already done this particular problem already. So we're going to say, okay, I multiply this by 20. Do I mean 20 or 20 over 20? Which one in this case? Just 20. I don't need 20 over 20. That's going to make your fractions huge. You don't want to make huge fractions, do you? You want to get rid of fractions. That's what we're trying to do here. Don't multiply by a number over something if you have an equation. So we have 20, we have 20, and we have 20. Not 20 over 20. What is it? 20 over what?
1.
Yeah, you can put 20 over 1 if you want to. So we found the LCD. We might have to factor that first here. We don't have to. We're going to multiply both sides. That means every fraction by the LCD. Multiply every term by the LCD. And the reason why this works is because you're multiplying both sides. I'm going to make a little note here. When you have equations, you're never multiplying LCD over LCD. You never do that. That doesn't work for us for equations. We're trying to get rid of fractions. We're not trying to make them bigger. Okay, this is not like addition and subtraction where you had to do that. Here you have equations, you have two sides. We're using that fact to get rid of fractions for us. How many people feel okay with what we just talked about so far? Good. Now let's see why this works. So we found LCD. We've multiplied every term by the LCD. That's right here. Hey, we know how to multiply. Does that simplify? What simplifies here?
1.
That's why we have the 1 down there, right? Because we don't need that 1 to simplify with anything. It's not. We're not going to make it 20. We don't need that. The 4 changes into a 1. The 20 changes into a
5.
And what's this going to be?
5x.
Here we have 5 goes into 5 one time. 5 goes into 24 times. So we have plus 16. On the right hand side, what happens there?
1.
Can you notice something? This is the easiest one to notice this on. I'm going to change it slightly. Don't change your problem, just watch. If I put 20 over 20, if I did that, that's going to be 20 over 400. Do you want 20 over 400? No. Probably not. That's not going to be very fun. You don't want to do that, right? You want something easier, not something harder. So we multiply every term, because we have two sides of this thing, by the LCD. We simplify what we can, and now we have a very easy equation after that. Isn't that nice? Isn't that nice? Something from fractions into something without fractions by one step. All you have to do is find the LCD. Don't do the LCD over the LCD, but multiply every term by that and cross stuff out. It's going to work. You will get rid of fractions. Now, after this is a very easy problem. Well, for you guys it is. Subtract 16, we get 5x equals negative 15. We divide by that 5. We get negative 3. We check our work. You can plug that in and check your work. That's going to work out, and we're done. So, a couple things. Of course, we still have to find the LCD. Of course, we're multiplying every term. You can't skip a fraction on this case. You can't do this, in other words. You can't just multiply these two and forget about this one, or multiply this one and forget about one of these. It's got to be every term in there. You have to do that. We're also just multiplying the LCD, not LCD over anything besides 1. It's not LCD over LCD, or it's not 4 over 4, 5 over 5. We're not doing that sort of thing here. We're trying to get rid of fractions. This is meant to eliminate denominators. Now let's try this with a couple more. We're going to build ourselves up to ones that look really hard, all right? They're not going to be very hard because you can get rid of denominators and it makes things really easy. But they're going to look really hard. So we're going to build up to that to see that we can really do this in any case. By the way, when I'm writing these problems down, I'll often leave a little bit of space in between the sign and the fraction because I know I'm going to have to multiply by something. Is that clear for you? That way you don't have to have it all crunched in. Oh, you know what? I made a mistake already. Change that to a 5, please. Okay, let's do this problem together. Now, one thing that I'm going to show you before we do even the very first step here is you might want to make things just like in the last last homework, make things into fractions first. Right here, do you see we have one term that's not exactly a fraction yet? Make that into a fraction. That way you don't confuse yourself with your LCD. Here, in this, that number wouldn't really matter for us, but the point is, let's make this into a fraction first. And how do we make a number into a fraction? Just do that real quick. That way you don't let that 15 get confused in your LCD. All right? Because if that number was like, I don't know, 30 or something, and you try to find the LCD and you consider that, that's going to make it a much larger LCD than what you need. Are you with me on this? So make your fractions first. Now let's go ahead and find our LCD. Let's look at those numbers. Our denominators are 3, 5, and 1. What's our LCD?
15.
Yeah, it is 15. In this case, it is that number. I just didn't want you to think that that 15 had anything to do with the LCD in this case, because it doesn't. It's just there. It just happens to be the number. So we're going to take it and write that LCD 15. What do we do with that LCD, ladies and gentlemen?
Multiply by return.
Okay. So that means definitely over on the right-hand side, I got to multiply that by 15. Hey, tell me something. Are those 15s going to simplify that? That's some yeses and some nos. What do you think?
No.
Is it like this?
No.
No. It's actually like that. Do you see the difference? So I gave you this problem. Don't automatically think that you can cross it out. It has to be set up correctly for you. Is that the only thing we need to multiply by 15? No. How many other things?
2.
So 15, 15. Let's make sure this is 1, 2. All three refractions are multiplied by 15, and we mean 15 over 1. That's fine. One more thing. There's something I'm missing right now in these problems that we talked about. What are we missing? Yeah, we're missing the parentheses. We're missing those parentheses. We talked about this. Every time you have a numerator, at least a numerator, with more than one term, you need parentheses because ultimately we're going to be distributing here, right? So you have to have the parentheses. So we're going to do this. Ooh, another important question. This one you should know because we already talked about this, but should I be distributing here or should I be simplifying here? I had two people say two different things. What do you think? What are we trying to do? Are we trying to make our numerators larger or trying to eliminate our denominators? Okay. If you distribute, you're going to make your numerator larger and still not get rid of your denominator. Are you with me on that? If you do that, look what you do. You have 15x plus 30, it'd still be over 3, right? How are you going to get rid of that 3? You're going to factor it back out to exactly what you have right here and then simplify. So if you distribute now, you're wasting 2 steps. You're wasting distribution and you're wasting refactoring. Get exactly the same thing you have right there. But this is why I have you think of this in class, right? That way when you get home, you're not like, oh, what do I do now? So we don't want to distribute. Remember, you're trying to get rid of denominators. That's what you're trying to do. So do it as soon as you can. That's right here. So don't distribute now. Eliminate denominators now. Do you see that we can eliminate the denominators now?
Yes.
This really is 15 over 1. This is 15 over 1. That's 15 over 1. We have the same situation we had over here. It has to work this way because we're using our LCD. That LCD combined the factors of our denominators, so they must go into it. What goes into both 15 and 3? What goes into both 15 and 3? 3 does. It has to work, right? 3 has to go into itself. 3 has to go into 15 because that's how we got 15. So we're going to cross out the 3 and put a what?
1.
We're going to cross out the 15 and put a what?
5.
And the 5. 5 goes into 5 one time and it goes into 15 3 times. Again, do these 15 simplify?
No.
No, we can't do anything with that. So we're going to continue. We're not going to distribute right now. We're going to just rewrite the problem, just like you did with addition and subtraction. We don't distribute because I can't have you miss negatives or things like that. So we're going to say, okay, we've got this 5 here, and we have the x plus 2. By the way, nod your head if you're okay on getting the 15 and using it appropriately, just like that. Are you okay on why we're not distributing right now? Why we're not distributing up here? We want to simplify that first. That's the main goal here, so do that. What's the next thing I'm going to write? Minus. Okay, great. We can't forget about that. And then there's 3, and then there's x minus 1. On the right-hand side of our equation, how much do we get? Good. do you notice what's going to happen here and why I can't have you distribute until this step? If we distribute up here with that 3, some people are going to forget about that minus, right? They're going to give me minus 3x minus 3. When in fact what we're going to get is minus 3x. Everybody's going to get that part. Everybody always gets that part right. It's this one, the second one, that's important because that's going to change the value of your final answer here. So that negative, that's going to distribute. We get our 5x plus 10, no problem there. That's an easy one. Minus 3x, but then sure enough, we're going to get plus 3. And that's kind of a big deal. If you get minus 3 there, that changes everything. Okay, hey, we've seen things like this. This looks a whole lot better than that one, right? No fractions, we just have something simple. This is like pre-algebra stuff. This is pre-algebra level right here. It's combined like terms of solving basic equations. What do? Or did I just give it away?
Yeah.
Just give it away. Oh. So we combine some like terms, we get our 2x plus 13. Subtract that 13. We're on the home stretch now. What is that, 112? Or 212, sorry. Last step is always to divide, so when we divide, it looks like we're going to get 106. Would you raise your hand and feel okay on doing a problem like this? Good, I'm going to give you one to try on your own. It's similar, just make sure you can go through this process, okay? I want you to try it once before we go any further. So go ahead and do that one. I need you to do everything that we just talked about. So there's no factor involved here on the denominators because they're just numbers. But find your LCD, use that, use parentheses where you need to, and figure out what that's going to be. Should be almost done with that first one. Hopefully you found the LCD. Hopefully you multiplied that appropriately. Definitely need some parentheses on that problem. Distribute correctly and then solve the basic equation. So first thing, what'd you find for your LCD in our problem up here? Are we trying to find common denominators or eliminate denominators altogether? Which one? Trying to eliminate. That's good. Ladies and gentlemen, when you get to your test, you're obviously not going to have me telling you what to do on this problem, right? I'm not going to say, oh, you need to eliminate your denominators. You're just going to have to know. What tells you up here, everyone should know this at this point, what tells you up here that you can eliminate denominators rather than just find a common denominator? Good, that's very good. So if you have the equal sign, you know you can eliminate. Are you with me on that? If you don't, can you eliminate them?
No.
Just find common ones. That's the difference. Okay, so we have our LCD. We're going to be able to eliminate denominators, but in order to do that, you have to multiply every term by the LCD. That's both sides, every term. Not LCD over anything besides 1, because we're trying to get rid of things, not make it worse. We definitely have to have some parentheses. I hope you put that. And now we get to do the fun part, which is simplify some stuff. We don't want to distribute now, we want to get rid of things. So the 12s, oh, you know what? I just know that. 12s are gone. The 4 and a 12, well, that simplifies to a 3 over 1, because the 4 goes in 4 one time and a 12 3 times. 3 and 12, that's going to give you that 4. How many people made it that far? Good, fantastic. We continue. I'm not going to distribute it yet. I'm going to write it just to make sure I see what's going on in this problem. We're going to have 3 times x plus 4 minus 4 x minus 3 equals 1 over there. After this, really, I mean, this shouldn't be too bad, right? This is just distribution, combine some like terms, and solving a basic problem without even x squared. That's nice. So here we'll distribute. We'll get 3x plus 12. 4x plus 12 equals 1. So far, so good? Good, all right. We continue. We're going to combine some like terms. If I combine like terms, what do I get? Perfect. Keep going. Subtract 24. Negative x equals negative 23. If negative x equals negative 23, x equals how much? So you can divide by negative 1 here, or just switch both signs, that's fine. Yep, we're going to get positive 23 out of that. Now the next one. The next one's the first case where we have something a little bit different here. What do you think maybe the first thing that we should do is on this problem? Okay, that might be a good idea to make them all into fractions. That's great. So here we have 6 over x. That's awesome, but that's our only fraction. Let's change them all into fractions. In order to do that, really, we just have to put this over 1, over 1. And over 1. Take a look up there. The next thing for you to do would be factor. There's nothing to factor. And then find your LCD. Can you tell me what is the LCD in this problem? X. Do you notice how the LCD has nothing to do with the 2 or the 7 up there? Do you guys see that? That's one reason why we write them as fractions first, so we get those numbers out of our head. We're just looking at 4 denominators. We're looking at 3 1s and an x. So the LCD, yeah, it's got to be x. Not sure if you're still okay on that. Okay, so LCD, yeah, we're getting x. Okay, folks, what do I do with that x? Next step. How many terms is that up here?
4.
Good. So that means here. That means here, definitely. That means here. Oh, don't forget about that one. And that also means, I can do it on either side. It doesn't really matter. Here. So 1, 2, 3, all times x. Not x over anything. X over 1. Maybe x over 1. You can put that if you like. But it's certainly not like x over x or anything like that. This should be an okay problem for us to do. Let's figure out. Let's figure out what we're going to have. On the first fraction, what do I get out of that?
2x.
Well, that's not bad. How about the second fraction? How are you getting the 6? Okay. X's are gone. Yeah, that's absolutely right. That's why we did that step, right? That's why we did this whole process, to get rid of that fraction. 6 is it. Equals, on the right-hand side, what are we going to get?
X squared.
Good. Yeah, don't forget the exponent. That's fantastic. And then how much?
7x.
Oh, do you see it? Look at What is that? We've seen that before. What do you do when you have something like that? First week of class. Hmm? Right now? Okay. You have an x squared up there, right? Can you solve this one like you did that one? No. Definitely not. Totally different problem, right? We found out that when you had the x squared, you remember the diamond problem? That's why we learned the diamond problem in the first place, to solve a problem like this. When you had the x squared, it said, if you don't remember this, go back and watch that. Man, it's good. It's like 9 parts or 11 parts. So every part was better than the last one. Part 11, oh yeah. Now, like I said, get everything to one side. 0 on the other side, that way you can use the zero product property, factor, and solve it. I'm not going to ask you about that because we've covered it so many times, and that's what we'll do. So we have our x squared. Let's keep that thing positive. That's already positive. That's great. Get these two on that side. Are you with me on that? You try to go this way, it's going to be very hard to factor. So we're going to go this way. That means subtract 2x. We'll get 6 equals x squared plus 5x. We'll subtract 6. 0 equals x squared plus 5x minus 6. We've seen things like that for a long time now. You factored them so many times in your homework. It's not even funny. I mean, you've been doing this all the time. Now we have it equal to 0, and we know that from section C.1, if an equation like this is equal to 0, if the expression is equal to 0, we can factor this, set each of them equal to 0 by the zero product property, and solve it. Do you remember how to factor that? Hope so. It should be like in your head like automatically at this point. So we'll still have the 0 diamond problem, no extra step here, that's no big deal. We just have 5 and negative 6. I'm thinking positive 6, negative 1. That's coming to mind. Were you thinking of those numbers also? So because there's no extra step, I just do x plus 6, I do x minus 1. Am I done? No, I'm close. I'm very, very close. All you have to do from here is set each of these things equal to 0. This is the case where you do that because it is equal to something, right? You can actually solve these. You don't just have to manipulate them, you can solve them. So we'll do x plus 6 equals 0. X minus 1 equals 0. We're going to subtract 6. We'll add 1. And we're done. Raise your hand if you feel okay with that. Good, good deal. Maybe I'll give you one of these to try and just try it. Right now I want to go into a couple other ones. We'll do about 2 more. We'll do 2 together. I'll give you a couple to do on your own and call it a day. Do you need one like that to try on your own, or do you feel good about this? You want one of those? I'll give you one later then. Okay. Yeah. See, it's getting better. It's getting better. Now, they look more nastier. Whatever. They look more nastier, but they're not going to be any different from what we just did. Okay? Not any different from what we just did. All you have to remember is that you're finding LCD and using the LCD to simplify denominators. That's what you're doing. In order to find the LCD on this problem, though, you have to do something first. What is that thing first?
Diamond the first one.
Okay, and that means we're going to factor that. So right now on your own, I'm going to do on the board, factor that right now. These two, you're fine. They're already factored out. Did you factor it?
Yeah.
I know one's positive, one's negative because you're getting a negative at the end. I know the bigger one's got to be positive. Hopefully you found 5 and 3, 5 and negative 3. I'm probably going to stop showing you the diamond method on the board because we've covered it so many times, you know just how to do it. So I'm encouraging you to find the numbers like that. We need to be able to do that on your own at this point. You can find the x plus 5x minus 3? Okay. Hey, you're also pros at this. Let's find our LCD. LCD is a listing of every different factor that you have. Can you see the LCD up here?
Yes.
What's one factor I need?
X plus Y.
Okay. What's another factor I need?
X minus 3.
What's another factor I need?
That's it.
Is that it? Okay, those check. X plus 5, we have that. X minus 3, we have that. X minus 3? Already got that. We don't need it twice. X plus 5? Yeah, we got that. That's fantastic. That's our LCD. Now, what do you do with the LCD? First question. Should I be multiplying X plus 5 over X plus 5 right here? No. If I didn't have this, ignore this side. If I didn't have that side, that's exactly what I'd be doing right here. Do you see what I'm talking about? That's exactly what you'd be doing. You'd have X plus 5 or X plus 5, you'd have a common denominator, you'd combine them. That's what you would do. As soon as I have an equals and some other fraction, that changes the plan. That says, oh, equal sign, now I can get rid of denominators. That's the goal now. So that's the goal. That means we're going to do this process on that problem. We're going to take the LCD and multiply every term by the LCD. So it might get a little long here. Okay, that's there. Okay. Sorry, I know it's a little squished. I broke my own rule. Can you still read that a little bit? Still read that? And back? Okay, good. Are you okay in this process? Do you see how it's exactly the same as what we just did over here? It's just now we have different factors. Can you see anything that still simplifies? Let's look at the first one. Remember that this is still all over 1, if you want it to be like that. And you're still multiplying. And this is all over 1, and you're still multiplying. And so is that one. And you're still multiplying. What simplifies in this first fraction? Tell me that.
X plus 5.
Just like you're simplifying it like normal, right? You extend the line, we know how to do that. You simplify those out. X minus 3s are also the same. Tell me what we get out of my first fraction.
7x.
What's the next thing I'm going to write? Good, minus. You see the minus? Awesome, we got a minus. Can you look at the second fraction and tell me if there's anything else that simplifies in that fraction?
X minus 3.
Do you notice how if you do this process, you will for sure, you have to, if you found your LCD correctly, you have to get rid of your LCD. I'm sorry, your denominators. Do you see that? You're using those factors in your LCD. So when you multiply it by it, it's automatically there. It has to cross out. There's no other way around it. Unless you do something silly like distribute all this. You go, oh, let's distribute that, distribute the 4, and then you can't cross anything out. And then you're kind of stuck, right? You have to go back and refactor it. It's very hard to do. We don't want to do that. So here we go. Oh, yeah, perfect. X minus 3s are gone. How about X plus 5? Can I cross out the X plus 5 here, folks?
No.
Okay, so I already have the minus down. Tell me the next thing I'm going to write.
4.
Oh, don't forget about the 4. That's there. And then what else? Do you see that when we write it like this, do you see that that negative is going to distribute? Do you see that? Okay. Some of you guys are zoning out here. Zone in. I only need you for 12 more minutes. Let's get going on this. So yeah, that's going to distribute. Then we have an equal sign. What's the next thing I need to write? Minus. Okay, that's good. That has to be there. What crosses out on the right-hand side? How about the 2? So I still need that, and I still need the X minus 3. Yeah, I don't think it's just me. I think this looks a whole lot easier to do than that problem. Don't you think that? This looks a whole lot better. This has no fractions. It doesn't even have X squared anymore. We crossed that out. This is awesome. This is what we want to have. Now all we need to do is what we did on that problem. We're going to distribute, combine like terms that we have, and solve it. So distributing, we have 7x minus 4x and minus 20. See where the minus 20 is coming from? Good. On the right-hand side, minus 2x and plus 6. See where the plus 6 is coming from? That negative is distributing on us. And when we combine some like terms, remember like terms mean on either side of the equation. Here you have no like terms. Here you have some like terms. We'll combine our x's we get 3x minus 20 equals negative 2x plus 6. Next question I have for you that I want you to answer. Am I supposed to get everything to one side and 0 on the other side on this problem? Is this problem the same as this problem?
No.
What's the difference?
Doesn't have that x squared.
All right, x squared, that's what we do. That's the only way we know how to solve it right now. You get it equal to 0 and you factor it. Do I need to do that here? The answer is, I don't even have an x squared. This would do me no good over here. This is get rid of the smaller variable, and then you have something very easy to work with. What's our smaller variable up here? So how do you get rid of that? Perfect. So we get 5x minus 20 equals 6. Good, add 20. Okay, now we're on the home stretch. I'm going to move over here. 5x equals 26. Our last step is always to divide if there's a coefficient. That's it. As good as we can do on that problem. Is it okay to get fractions out of a fraction problem? Sure. There's only one thing that you need to check. Okay, I need to make sure that you see this. Watch up on the board here. There is one thing you need to check. You need to make sure that you can plug this number in and that it's legal to do that. Here's what I mean. Notice we have fractions here, right? What's the one number you cannot have on the bottom of a fraction?
0.
So if you were to plug this in and it made 0 here, or 0 here, or 0 here, you'd have a problem, right? So you plug that in. Is 26/5 minus 3 going to give you 0? No. The only thing that would give you a 0 would be a 3 here, right? The only thing that would give you a 0 here would be a negative 5. Remember talking about the domain stuff? So you check that. Just make sure that this number is not going to give you 0, and you're okay. That's a solution. If it gives you 0, then you cross it out. It's not a solution. We've understood that problem. Good. All right. Okay, like I said, we're going to do one more together. I will give you 2 to 3 to do on your own, and then we're done. Honestly, we already had this section kind of covered from the first day of class. I mean, it's the same stuff. It's just now you're working with expressions like those. So, same idea. So we're going to do that and then give you some practice. Okay, last one we're doing together. I want you to walk me through it though. Tell me what I need to do first. Tell what I need. Quickly, let's go.
3 over 1.
3 over 1. Great, that's a great idea. We can do that. What's the next thing I need to do? Okay. LCD might mean you have to factor. Here we don't have to. That's fine. Everything's factored for us. The reason why we put this over 1 is so we don't confuse this 3 as part of our LCD, because this 3 is not part of our LCD. What is our LCD here? Well, that's not bad. I like that. Okay, we have LCD. What's the next thing I'm going to do right now? Okay, times how many things?
3.
So that's here, I'll put it in parentheses. That's here, I'll make sure it's in parentheses here. And that's also here. Should it be x minus 1 over x minus 1 or just x minus 1?
Over 1.
Over 1. Okay, we can do that also. Why am I able to do this? Why can I get rid of denominators? What tells me I can in this problem? Good. Okay, so maybe I put this over 1 if you want to show that. That's fine. Let's cross some stuff out. This is the best part of this process. Let's cross some stuff out. Here I see the x minus 1s are gone. What am I left with? Then I have an equal sign. I see the x minus 1s are gone. I get what? And then over here I have plus 3 times x minus 1. I'm not going to distribute, just in case that was a minus sign, because I want to see that. So I wait for distribution, just one step, not a big deal. 5x plus 5, sorry, equals 5. And then we're going to get the 3x minus 3. Still okay so far? Next step, what do we do? Quick. So we have 5x equals 2 plus 3x. That's combining like terms. Next step is, well, either A or B. Choice A is you get everything to one side and 0 on the other side. Choice B is you solve this just like it is because you don't have an x squared. Yeah, choice B. So we're going to do what?
Minus 3x.
Perfect. We get 2x equals 2. Very good. And the last step is? And we get x equals 1. How would we feel good about that solution? I would too. I would too. Except, I want you to look back. We just talked about this.
That makes it.
Is that a solution?
No.
It looks like it, right? We solved it. We got an answer. Look back at the original problem. Take that 1, plug it in, look at the denominator. Is that okay?
No.
Here, hey, that looks good. It's 5. Here, that looks fine. That's fine. That's fine. Here, that's fine. Here, oh crap. That's not good. What happened? We plugged in 1, we got a 0, right? On the bottom of our fraction. Why does that happen? The answer is, when you take this and you multiply it by the LCD, you're essentially moving this to the top of your fractions. You see what I'm talking about? Essentially, that's what you're doing. In doing that, you can create some false solutions. This is a false solution. So what you do, you get all the way down to here. That one worked just fine. That was fine. It didn't make 0. This one, this is a problem because when I plug this into the denominator, it gives me 0. That's undefined. If you get something that's undefined, all you got to do is solve it down. You're not going to do it until the very end. Just cross it out. That's not a solution. There is no solution to this problem. I know you're not used to problems not having solutions, but this is one of them. Okay, I'm going to give you 2 problems to do on your own. One similar to this one similar to the one we did over here. Okay, so there you go. Work on that one. I think I'm going to write 2 on the board. I think we can go pretty quickly through these. We gotta get started on the first one, or we're not gonna have time on that. So on the first problem, of course we're gonna make this all over 1. I hope that you did that. I hope you found your LCD. Your LCD is what here? Good. We're gonna take and multiply everything by x. Really x over 1. We can show that if we want. Here we'll get 8x. We'll get, oh, those are gone. We'll get plus 7. We'll get x squared, and we'll get plus 2x. How many people made it that far on that problem? Very good. Now, do we solve this like it is, or do we have to get everything to one side and 0 on the other side?
Zero.
Gotta get 0. Otherwise, the factor's not gonna make a difference. So 0, we're gonna move the left to the right, or the right to the left? Okay. So minus 8x. 7 equals x squared minus 6x. We'll subtract 7. 0 equals x squared minus 6x minus 7. You still with me on this, folks? We'll do what now?
7.
I'm thinking minus 7 plus 1. You're not quite done yet. You do have to set them each equal to 0. X minus 7 equals 0. X plus 1 equals 0. We'll add 7. X is 7. We'll subtract 1. X is negative 1. You have to check one thing. Make sure these denominators don't make this 0. They don't, because they're a positive and negative number. They're integers. So we're good. They're both solutions in this case. Now, the next ones, we don't have time to go over. I only have like 10 seconds. Do you know how to do this one? What would you do first? Great. Factor, find your LCD, multiply 3 things by that, simplify, distribute, and solve it. You don't even get x squared on this problem. This one, can you see your LCD already? Just multiply everything by x plus 3. Distribute. You will have an x squared. Get everything to one side and solve it. What I'm going to, these are our last 2 problems. We'll do them the first maybe 5 minutes of class next time, and then I'll post that with this lesson. But we're essentially done. That's it, and that's all we got to cover. So I'm going to give you your homework. It's not going to be due tomorrow, but I really do need you to start on it because we're probably going to have another homework assignment tomorrow. Okay? So you need to get almost done with this assignment. So here you go. So if you remember from last time, we were about to do these problems. Can you tell me what's the first step in doing the problem on the left-hand side, which we need to know?
Factor.
So let's factor that. These 2, of course, are factored, but this one we'll take and factor at 6x, and we'll get x plus 2, x minus 7. So we should know how to factor the diamond method, no big deal. After you factor, what's the next thing we should try to do, folks? Okay. Can you see the LCD up there right now? What is the LCD for us? So we have the LCD. Now what do we do with that? Are we trying to find a common denominator, or are we trying to eliminate denominators? What do you think? Great. How do we do that?
Multiply the numerator.
Okay, so everywhere we see a term or a fraction, we're going to multiply the entire LCD. What that's going to do is simplify out all of our denominators. Remember, if you make it to the next step and you still have a fraction, you've done something wrong, go back and fix that. So everywhere we're going to have, in our case, x plus 2, x minus 7. Even over here. Notice that the reason why we can do this is, again, what do we have up here that we didn't have on the last section's homework? That's why. That's what tells you can do it. If you have an equal sign, that means you can multiply both sides by the same thing, or in other words, every single term. We can simplify out our denominators, and that lets us do this problem very easily. So what simplifies up here? How about in our first fraction? What are we going to have left?
6x.
That's great. So all of this stuff is gone. We have 6x. Then we have a minus sign. And what simplifies over here? Now, are we going to distribute now or wait till the next step? What do you think? Yeah, we're going to definitely wait because we want to make sure this minus sign gets distributed with that 3. That's an important step. I'm still seeing that on some of your homework that you're not distributing negative. So when you get this homework back, some of you have the wrong numerators, and I've crossed it out because you're not distributing the negative, and you're adding together like terms that really shouldn't even be there. So be careful on that. Over here on the far side of our equation, the x minus 7s are gone. We have x plus 2. And now we're kind of on the home stretch. This is a very basic problem considering we started with that. I mean, just one step, and we have something very nice. We're going to distribute. So 6x minus 3x, and of course we're going to get plus 21. Do you see where that's coming from? Equals x plus 2. We're going to combine some like terms if we can. Here we have 3x plus 21 equals x plus 2. Get everything to one side or solve it directly? What do you think? One side. Do you have an x squared?
No.
So do I have to get everything to one side?
No.
Okay. So we're going to subtract the smaller variable. From there, it's a piece of cake to solve. We get rid of a constant, and our last step is to divide. So we'll subtract 21. Divide by 2. And unless we made a mistake somewhere, that should be our answer. How many will feel good about doing a problem like that one? Good. Middle row, are you guys okay with that? Yeah? Okay. How about left row? Are you guys okay with that? Yes, no? Yeah, okay. So the whole idea is factor, find your LCD, use that if you have an equation to simplify your denominators. After this, I went through this really quick because this is old stuff. I mean, this is really, really old stuff. So this from here should be like a no-brainer. The only thing I've taught you in this class is how to do, well, factoring, LCD, and then using that to get down to this stuff. This is really this class right here. This stuff is all pre-algebra stuff right here. Okay, now the next one. We're going to go ahead and look at this. Before I even think about the LCD, what should I do?
Make sure you don't have denominators.
Okay, so maybe make these things into fractions so you're not considering this and this as your denominator. So we'll do that. We'll change this into 1 and over 1. Ladies and gentlemen, everybody, what is my LCD here? That's great. Okay. What am I going to do with that LCD?
Multiply by each term.
How many terms are there here? 4. So that means here and there. Am I doing x plus 3 over x plus 3 or just x plus 3? What do you think? Good. So I'm going to do x plus 3. And here, I'm going to have some parentheses. Of course, if you want to show it over 1, you can do that as well. I don't choose to because we really know what's going on at this point. Do you see anything that's going to simplify?
X plus 3.
How about here?
No.
But before I distribute that, I'm just going to write it a little bit different, just to make sure I stick with the same process here. I'm going to write it x times x plus 3. No problem, nothing simplifies there. How about the next fraction? Does anything simplify?
And the other.
So what am I going to have?
Negative 6.
Okay, that's the left side. Then I add an equal sign. Here I also see the x plus 3's are gone. I get 2x. And then I get plus 2 times x plus 3. Again, I'm not distributing it in my head because I want to make sure that this sign, whatever it is, gets distributed. That's kind of an important process for us. Okay. Well, that already looks a little bit better. What are we going to do next?
Distribute.
Let's do it. What am I going to get when I distribute this first?
X squared plus 3x.
I still have that minus 6. Then I have 2x. And I'm going to get 2x plus 6. Keep going. Someone on the right-hand side of the room. What now? Okay. Do I have any on the left side? Right side?
Yes.
Okay, now, here's where you need to know what to do. Either you know what to do or you're going to get stuck on this problem. Do we get everything to one side or do we solve it directly? What do you think? Why is that different than this? That's right. That's exactly right. So here I'm going to keep the x squared positive. I'm going to move this stuff over to the left-hand side. So minus 4x. Then,
Minus 6.
let's do that. We can't do this, we can't factor yet because we don't have the 0. We need a 0 over there for the 0 product property to work. So that's why we have to keep going and get x squared minus x minus 12 equals 0. That 0, that's really important. We've talked about that a few times in here. You have to have the 0. Okay, we have the set equals 0, and now what do? Yeah, the diamond method says we're gonna factor that thing. In here, at this point, we should be really good at factoring these problems. There's no extra step. It's pretty basic. We're going to get x minus 4 and x plus 3. So far, so good?
Yeah.
Are we done?
No.
Now what?
Set each one equal to 0.
Okay. One last little step. We add 4, we get x equals 4. We subtract 3, we get x equals negative 3. And we're done. How many will feel okay with solving these things? Good, very good. Now, we get to move on to chapter 7.6, or lesson 7.6, I should say. And in this section, we're going to talk about how to solve some problems. I'm going to give you a couple techniques. We'll be able to deal with several different problems. I know problem solving is probably not your favorite thing in the world to do. Yeah.
Isn't the negative 3 plus 3 equals 0? And that will cancel it out.
Oh, good. Yeah, we forgot to check that. Yes, you do need to check your answers. So the 4 works. You caught the negative 3. Does everyone see what she's talking about?
Yeah.
I said last time I broke my own little rule. Good catch. I was just testing you. You passed. Yeah, the 4 is just fine because we plug that in, it makes 7 and 7, but she's absolutely right. The negative 3, if I put that in there, I get 0 on the denominator. That's not a good thing. So you do have to cross that one out. Yeah, we only get one solution there. Good call. Thank you. Okay, anything else that we've got up there?